Question number 6 on Newton's law of, once again, cooling or heating, right? HVAC, those applications. Let's read it in here. Number 6. Okay, Bryce, go ahead please. Number 6.
Temperature of an object in degrees Fahrenheit after T minutes is represented by the equation T of T equals 68 e to the power of negative 0.0174 T plus 72 to the nearest degree. What is the temperature of the object after 1.5 hours?
Thank you, alright. So again, this is what? Temperature in Fahrenheit, T minutes, and that is the equation, right? To the nearest degree, what is the temperature of an object after 1.5 hours? Good, guys? There we go. Now, let's see first our formula for Newton's law of cooling. Here it is, right? We said in here, T of T, right? It's a lot of T's in here, right? So this is, what you call this? If you're using password, what you call this? Case sensitive, right? Okay. Big T for temperature, small t for time. Get it, guys? Okay. Big T, small t. Okay. Temperature at a given time. Surrounding temperature. Okay. A is what? Initial minus surrounding temperature. E to the KT. K is the rate of cooling or sometimes heating. And T is the time element. Can be in hours, minutes, seconds sometimes. Good? Right. Now, in here, it says what? To the nearest degree, what is the temperature of the object after 1.5 hours? But as you may notice in here, your T is in what? Is it in hours, minutes, or days, or seconds? Minutes. Thank you, right? So with that being said, T, oops, okay. We're solving for what in here? The temperature. Okay, here we go. There. The temperature at, when you say 1.5 hours, how many minutes is that gonna be? 90 minutes. Thank you, right? So again, you don't do 1.5 because T is in minutes, right? So you do 90 minutes. Again, please be specific with time element, all right? Be careful with those. Surrounding temperature, what's the surrounding temperature there? 72. Good, right? Plus, what's the difference between the initial and the surrounding temperature? 68. Okay. E, as you may notice, everything is already given for us anyways. Negative 0.017 times T. And what's your T? 90 minutes. Good, right? Now it says in here to the nearest degree. How much is that gonna be, right? Once again, the 68 in here is the difference between the initial and the surrounding temperature. K is the constant or rate of cooling or heating sometimes, okay? 90 as your time, right? So let's use our calculators for such. Again, this is basically just a calculator work and put everything in there, right? 72 plus 68 E shift 6 for exponent. What's that again? Negative, negative 0.017, right? Times 90 minutes. We good? Right. So in short, after 1.5 hours, right? What is the temperature to the nearest degree? Kinsey. 86 or 87?
87.
87 degrees, right? So again, after 90 minutes or 1.5 hours, it would be, how much is this? 86. Well, 87.
Oh, there's supposed to be 4 besides the 7.
0.017. Let's see. Did it say 4, guys? Let's
Yeah.
see. Oh, did it say 4? There, let's see. Let's go back to the problem. Oh yeah, 0.0174. What? Thank you for that one. In here, Eva. There we go, right? Yeah. 86, sorry for that. 86 degrees, right? So, put it here, 86 degrees, right? So, the lesson learned, Please be careful with those numbers, right? Yeah, especially myself. I have 4 eyes. Sometimes the exponent, you cannot see the numbers anymore, right? You forgot some numbers in there, right? Just myself, right? So 0.017 and there's a 4 in there, right? Are we cool, right? And also, definitely, look at the time element. Is it in hours? Is it in minutes? Is it in seconds? Check it out in there, guys. Are we cool? Right? Let's solve one more problem in here. Definitely, this is just an evaluation problem, right? But what about a typical problem for such? Let's read this one in here, okay? Okay. Thanksgiving turkey. Ooh. Right? We good? Either it's fully cooked, raw, or dry. Because of which means it's overcooked, right? So how do we do this turkey thing, right? Let's read this one in here, okay? Magnolia, go ahead, please. Turkey.
For the following exercise, use the scenario a turkey is taken out of the oven with an internal temperature of 165 degrees Fahrenheit and is allowed to cool at a 75 degrees Fahrenheit room. After half an hour, the internal temperature of the turkey is 145 degrees Fahrenheit. What is the formula that models this situation?
Thank you. All right. So let's read this one that first, right? What formula will model this situation, right? So once again, going back to the problem in there. First of all, let's define some terms first. First of all, what is TA? What is the surrounding temperature? 75, right? Very good, right? Because the turkey is cooked already. Hopefully it's fully cooked, right? It was taken out of the oven, right? At a room that's 75 Fahrenheit, right? So that's the surrounding temperature, right? We good? Right. Next, A is basically what? A is basically TI, the initial temperature, minus the surrounding temperature, right? So let's read that. Let's see first. What is TI? What's the initial temperature, right? Evan.
75? No, 165.
Okay, so it says in here, a turkey is taken out of the oven with an internal temperature of 165 Fahrenheit, right? Typically, it would say anything that's poultry-based, it has to have like what? You stick a thermometer in there, it has to be what? 165. If it's not 165, don't eat it. Are we good? Don't eat it. Trust me, right? Chicken, if it's not 165, question mark, right? Be doubtful about those, okay? So, are we cool? Right? It has to be cooked. For steak or red meat or pork, I guess it's not too strict, but for poultry, be careful, guys. We good? 165, okay? Okay, what else? What is this 145 then? Well, T first. What is the small t? Time element? Small t. How long did it take? Half an hour, right? So when you say half an hour, we can say 30 minutes. You good? Okay. Half an hour is 30 minutes, right? Okay. And what's this 145 then? That's what? T after 30 minutes, right? Because it says after half an hour, the temperature of the turkey was seen at what? Read at 145. Are we cool? Okay. Well, let's solve for what? What do we need to solve for in here, right? Let's put it in here and see how it looks like in terms of the equation itself. Let's put it in here as follows, okay? So T, oops. T after 30 minutes, it says how much? 145. We good? Okay. E is equal to, what's the surrounding temperature? 75. Very good. Plus, what's your A? Your A is what? Initial minus surrounding, right? So what's that? What is initial? It's 165 minus 75. What's this gonna be? So to get your A, check it in here. Your A is what? Oops. TI minus surrounding, right? What's that gonna be? 165 minus 75. How much? 90. There we go. Right. So your A is 90. Okay. So once again, initial minus surrounding. Okay. 90. E. K, that's what we have to solve for. And your T is how much again? Half an hour or 30 minutes. Are we good? Well, let's solve for that K. Okay. Solve for this K in here. So what do we do first in here? Step number 1, write it at the form what? Y is equal to what? A, well, right? So write it at the form first. E to the KT power is equal to C, right? So let's C in there. In short, we just need to what? Have this one on one side of the equation, right? So how to get that one, right? So how do we do this? Do we remove 90 first or do we remove 75 first? 75, right? So what do we do? Subtract, right? So subtract 75 both sides. Here it is. So this will cancel out. Okay, what's that gonna be, guys? Regan, 145 minus 75. 70, very good, right? So 70 is equal to what's this? 90 e to the 30k. Well, we just want this, right? So what do you do to remove the 90? Aiden? Divide, very good, right? Divide 90 both sides. Again, do not round off, express it in exact answer or value. In short, fraction. We good? Okay. So don't write this in decimal. Leave it as it is, exact fraction, right? So cancel this, hence we got what? E to the 30k is equal to 7/9. You good? Okay, so we have written that one in this form already, right? You know, solving exponential equation. Okay, step number 2, what do we do then? Take the natural log, right? Convert to log. Very good, right? Convert to log, okay? Right. So in short, how do you convert this to log? ln, right, of what? C is equal to what? KT. Get it? Okay, so do that one in here. So how do you write this one in there, guys, right? ln of what?
7/9.
7/9, very good. Again, do not convert this into decimal, all right? Leave it as it is equal to what? 30k. Good. Last one, what do we do? Well, you just want the K, right? The rate of heating or cooling, okay? So what do we do after that? Well, you want the K, Candy? Divide by 30, there we go, right? So solve for K, right? Solve for K. So divide both sides by 30, very good. Hence, we can rewrite the formula already for such. So let's put it in here for number 43 as follows, right? So what's the formula in here? Y, so everything in here, number 43, right? T of T is equal to, what's our surrounding temperature? 75 plus, what's our A? 90, right? E, what's our K again in here? It is, what's that? 1/30 ln 7/9, right? Okay. Or let me just, so I'm gonna put the K in here, right? Let's start again. ln 7/9 over 30, right? That's your K times T, right? So I can just put the T in here or in here. Okay. But basically, that's our formula, right? T in terms of time is equal to 75, that is the surrounding temperature, plus the difference between the initial and surrounding temperature times E to the KT. Okay. So that is the formula for this situation, okay? Let's read number 45. How do we use this one then, right? Lexani, let's read number 45.
To the nearest minute, how long will it take the turkey to cool to 110 degrees?
Right, so you can solve for that T as well already there, right? Let's read number 44 for that. Olivia, go ahead.
To the nearest degree, what will the temperature be after 50 minutes?
Okay, so after 50 minutes, so this number 44 is a little bit easier. What we're gonna do? Number 44, so you just change the T into what? 50 minutes, right? As you may notice a while ago, the half an hour, that's why we changed it to 30 minutes, so that in here, we can write this one into minutes as well, right? Because you might be thinking, Mr. Deal, it says half an hour, why didn't you use 0.5 hours? Because as you may notice on the situations in here, all the time element are in what? Minutes. Minutes. Okay? That's why we did it 30 minutes instead of half an hour. So put it in here as such. T after what? 50 minutes is equal to what? 75 plus 90. E, what's your T again? 50, right? So the 50 times what's this? ln, 7/9 over 30. Also, as you may notice, the K, I did not round it off. Why didn't I round it off? Because it didn't say in here anything about rounding off your K. So I just left it as ln 7/9 over 30. Right? Let's put it in there, right? On our decimals calculator, like such. Okay, what's our equation for that? 75 plus 90E, shift 6 for the exponent, 50 minutes, right? ln 7/9. And again, be careful with this copying this one as well, right? Now this is what I'm gonna do, right? I'm gonna highlight the ln 7/9 first and then divide it by 30. Are we good, guys, with what I did? Right? So how long will it take to the nearest degree? 134 degrees Fahrenheit. Okay? Good. So I'll go put it in here. Approximately 134 Fahrenheit. Okay? So after 50 minutes, right? The turkey, which was what's the initial temperature? 165, right? After almost an hour, right? It's gonna be at 134 degrees Fahrenheit. It's still pretty warm, right? So even after almost an hour already of just sitting in there on the room that is 75 degrees Fahrenheit, it's still gonna be a little bit hot, right? Warm, 134. It's not bad. We good, right? Is it cold turkey already?